Hello guys, in this video I'll explain you the topic SFD and BMD. So first of all, let us understand what a beam means. A beam is any transversely loaded member that is acted upon by forces that are perpendicular to the axis. Okay, perpendicular to the axis. So this member will be known as a beam. Now, what there are three kinds of supports that you need to understand, that you need to know about. The first one is fixed or built-in support. This can be seen in the example of a cantilever beam. Cantilever is any beam that is fixed on one end and load is applied on the other end. Okay, so a fixed support can give you reaction in the horizontal direction, reaction in the vertical direction, and a reaction moment. Okay, this is the only type of support that can give you a reaction moment. Second type of support is hinge support. This can give you reaction in the horizontal direction and in the vertical direction, but it cannot support a moment. It cannot give you a reaction moment. Third type of support is roller support. It can support only vertical direction reaction. It can give you only reaction in the vertical direction. So now we have understood what a cantilever means. The second type of beam that you need to understand is simply supported beam. Simply supported, as the name suggests, it is just rested upon by two supports. It can be a roller support, it can be a hinge support. Now, let us understand what eccentric loading means. Eccentric loading. Eccentric means offset. That means, for example, if this beam is supported on these roller supports, one is this and one is this. Okay, now and a load is applied somewhat here. Let this distance be A, this distance be B. So in order for this beam to be in equilibrium, reaction will be there. Reaction will be acted upon by the supports. So the RA will be force into distance from this end, B upon A plus B upon total length. RB will be force into distance from that support, P into A upon A plus B. This can be used as a trick for easy solving of the questions. That means reaction will be is equal to reaction from this support will be equal to force into distance from that support upon total length. Reaction B will be force into distance from that support from the other support upon A plus B. Okay, so this can be used as a shortcut. Now let us take some examples in order for you to understand it clearly. Also, one more thing, there is uniformly distributed load also. Uniformly distributed load. In short form, it is known as UDL. Let us consider this UDL of magnitude W kilonewton per meter. That is, for every meter, W will be the magnitude that is acting upon on the beam. Okay. For it to solve, suppose W is acting and reaction is RA and RB. So, and this is W kilonewton per meter, length is L. So the total force that is acting on this beam is WL, because if for 1 meter it is W kilonewton, for L meter it will be WL, and this will be acting at the center of gravity of this force. Okay, so the force the reaction will be R is equal to, since it is symmetric, so WL by 2, and RB will be WL2 as well. Okay, now for take another example. If it is gradually increasing from 0 to this W kilonewton per meter, then the area of this load diagram will give you the total force. So what is the total force? First we need to calculate the total force. Total force will be area of this diagram. So area of this diagram is half into L into base into height L. So that is WL by 2. Now we need to calculate the reactions. What is the reaction? Now this force will act at the center of gravity of this diagram. center of this diagram, WL by 2, center of mass of this diagram, WL by 2. Center of mass of triangle is at a distance L by 3 from this end, 2L by 3. So this is 2L by 3, this is L by 3. The magnitude is WL by 2. So RA is, as I told you in the previous example, RA will be force into distance from that end, that is L by 3 upon total length L. So LL cancel, it comes out to be WL by 6. So RA will be WL by 6. RB will be force into distance from the other support, 2L by 3 upon total length. This will be WL by 3. So we have got the reactions now. Okay. So first reaction will be RA will be WL by 6, RB will be WL by 3. Now let us understand some sign conventions. We are taking for now LHS section, left hand section. This will be x axis, y axis. If any force is acting in the upward direction, it will be positive. If it is acting in the negative downward direction, it will be taken as negative. And this is for shear force. Okay. Now, and for bending moment for a force if a force is causing the beam to bend in this shape, it will be called as hogging and it will be taken as negative bending moment. If the bending moment is causing the beam to bend in this shape, that is, this is called as sagging, so it will be taken as positive. So the bending moment will be taken as positive bending moment. Okay, this you need to remember for every question. Okay, now let us take a simple example of a cantilever first, then we'll move on to some other examples, increasing the level of the question. Suppose this is a cantilever and this is it is being acted by a force that is 10 kilonewton in magnitude. Okay, and the length of the beam is 5 meter. Now your first step should be making the coordinate axis x and y. Okay, now we need to create shear force diagram and bending moment diagram for this. Okay, so this will be Vx, that means shear force, and x. So Vx, since the force is acting in the downward direction, so it will be taken as minus 10. Now throughout this length no other force is there, so throughout the length this force will be constant. Now for this beam to remain in equilibrium, the reaction will be given by this fixed support and it will be in the opposite direction. So plus 10 will be here. So this is the diagram for shear force diagram. This is your diagram for shear force. Now let me explain it once more. 10 kilonewton force is acting downwards, so it will be taken as negative, as explained earlier. Sign convention is important in this. Okay, do remember that. So minus 10, then throughout this length no other force is being acted on this beam, so it will be constant throughout the length, and then plus 10 force will act on it. Why? Because this is the reaction given by the fixed support. So plus 10 here, it comes out to this point 0. Then the shear force diagram that comes out is this one. Okay, now let us draw the bending moment diagram. It is denoted by mx. Bending moment is denoted by mx. Okay, you can write the equation as well. Mx will be, let us take a section at a distance of x from the force. Okay, let us take a section x